My name is Mariah. I'm just the timekeeper here, but I was going to introduce our moderator, Tom Clerkin. So Tom is part of Dr. Rachel Noble's Lab, University of North Carolina at Chapel Hill. He's a research specialist for Dr. Rachel Noble's lab at UNC Chapel Hill, where he's been involved in WBE since the onset of COVID-19 pandemic. He has played a pivotal role in collaborating with researchers, government agencies, and public health officials to develop a statewide surveillance program that currently monitors SARS-CoV-2, influenza, RSV, and emerging pathogens in 37 wastewater treatment plants across North Carolina. With the expertise in molecular methods, digital and quantitative PCR and assay design, Tom's recent work with the news focuses on training laboratories and optimizing wastewater processing methods, emphasizing high throughput capabilities and quality controls.
Great.
So go ahead.
Yeah, thanks for that. I'm really excited for this panel discussion we have today about different facets involved and methods needed to generate quality lab data. We have a really great group of panelists, and we have Krista Wigginton virtually over here, all from the Midwest, so great Midwest representation. And we have a really great group, and they're all doing great lab work in wastewater surveillance. We're going to start off this panel through a series of short presentations, about 3 to 5 minutes, and we're going to start with Ishi Keenum from Michigan Tech University. She'll be discussing the importance and implementation of reference materials, controls for wastewater, and we'll be followed up by our virtual panelist, Krista Wigginton from the University of Michigan, and she'll be discussing QA and QC elements and how they're implementing these quality control automations with different districts, and then we will be finished up with Dagmara from Wisconsin State Laboratory of Hygiene, sharing best information about their proficiency.
Just a quick note to let me know when to advance the next slide, please.
Perfect.
All right. Yeah, it's gonna get fun because I have animations, so I didn't realize that. But yes, next slide. I think we're ready, hopefully. Okay, so those aren't my slides. Those are Dagmara's slides.
I can go to yours.
Okay, can you go to mine?
Yeah.
Thank you. This would be really fun though.
We should do each other's slides.
I know. We'd be like, let's see.
Let me go to yours really quick.
I can see that.
Okay, sorry for the
No, you're good.
delay. I'm looking around for where it is.
Some music.
Yeah.
Would you mind coming and looking at which one's yours? Since I'm
Yes.
not familiar.
It'll be. Yes. No worries.
I got
choices.
this morning.
It is that one.
This one.
Yeah, starting there.
Okay, the first one?
Yes.
Well, good
Oh,
start.
okay.
I think so. Yeah. Yeah, you know it's that one.
Okay,
Exactly.
thank you.
going?
Drum roll, please.
Okay, I think we got it.
Give me 1 second.
Okay, so I'm gonna just give a little bit of an overview of kind of, you guys are probably in this room because you're interested in this and things that can impact your lab data. And so I, at Michigan Tech University now, I did my postdoc at NIST, the National Institute of Standards and Technology, and helped to lead the Standards for Wastewater Surveillance Working Group. And a part of what we thought about a lot at NIST and what I think about now in our lab is what impacts what we're going to quantify in wastewater. So what are the variables we're trying to assess? And then how can we account for those? And those are kind of two separate questions. So you don't need to read kind of everything on this slide, but the goal is to really show you that from sample collection through concentration, extraction, amplification and quantification, or sequencing, whatever you're doing, QA, QC, and results reporting, we have quite a lot of variables that we're trying to account for. And as we start to compare, within one lab across assays, maybe a lot of these things stay constant, but then when you're comparing across different things that you're trying to measure, you're changing the variables here. So even if you're just changing the PCR step, you're going to be changing things like your amplification efficiency, your primer bias, your amplification errors. These are all things that we want to establish controls and standards that we can kind of account for. And so kind of talking about what we can account for or what we can use to try to do that. Next slide. This one is the one that's going to have, that didn't pop up right. Anyway, so that's fine. So thinking about this workflow again, we can think about how different routine performance controls should be implemented at different stages, and they can be used to, for example, if you were thinking about your sample collection, what can you use for a positive and a negative control? And that could maybe control for like your field blank. If it doesn't pop at any point, it'll actually control for quite a few different steps in your workflow. You don't have to target every step individually. That's probably cost prohibitive for anyone to do reasonably. But we want to think about what different assays, for example, if you had an assay target reference material, that might be important for your PCR amplification or your data QA/QC, versus if you just have like a surrogate spike, that might be good for different parts of your workflow. But maybe your assay that you're using doesn't target your surrogate because you're trying to differentiate those two. The other thing I kind of highlighted here, but again, no one can see it, that's okay, is the reporting guidelines. And so the reporting guidelines right now, I think we have what's required by news. But I know as we think about proficiency testing or kind of standard methods and reporting we want across the board, we're going to have different metrics for different parameters that we need to think about. All right, so click once, it should switch up the box, we'll see. Okay, so if we want to think about what those controls might be, you could have like a near target control. So this is just an example from Zeptometrics. They have an influenza verification panel that targets 5 different types of viruses. So influenza A, B, RSV, and RSVA and RSVB. And that might be a good thing when you're trying to do method development. So you might want to differentiate, bringing on a new target, you might have different things that you control for to make sure it's working, or like that you're concentrating what you think you're concentrating, or what your losses are before you kind of implement it as a routine metric. And then you might want to, spot check as needed for what you want to do. All right, next, click. Let's see how this one goes. Okay, for PCR amplification, oh, that didn't vanish. All right, you can think about having specific DNA reference material that maybe you're not trying to control for the entire concentration process. You're just trying to make sure your assay is behaving and it's quantifying as it should. And I would recommend, even with digital PCR, that you should always have a standard included on your plate so that you should know your recovery every time, and you should know, did everything go well? Because people are not perfect. Machines are probably less perfect. We're all trying to figure this out. And so just knowing what should quantify at and that it checked, it did, is a good QA/QC that I think Chris is going to touch on more. And then next. Okay, we'll just keep clicking, don't worry. I tried to give a bunch of examples, but that didn't work. So there's another slide that is the animations. Okay, so other resources I just wanted to highlight that you guys can think about is that you can think about things like a whole organism, cell, or particle. So ATCC, microbiologics, Zeptometrics, NIST. I'm sure the list is endless. I've worked with different people who are trying to make either inactivated viruses or inactivated particles that you can spike in to really test your workflow for just a new target. You can also think about DNA control, so you can kind of make your own. It's a little bit more recommended that we might all start from a known quantified material so that you can check that you're getting the same numbers that everyone else is, which is especially important as you go to do your calculations for your reporting, because that's where we find are actually huge errors, is that the way we're doing the math is not consistent. And that has huge implications for trying to make comparable data. And the math arguably should be the easy part, because you can redo it. Okay, that's all I wanted to touch on. I think next is Krista. I think her slides were the next one in yours, so that should just keep going. But thank you so much.
Yeah, thanks for that. Ishi.
Yeah, sorry that animation. I tried to get creative and I should not. Okay.
Yeah, so now we have Krista Wigginton from University of Michigan, kind of talking about how they've been implementing these different controls that Ishi was just talking about.
Yeah, so is my sound okay?
Yes.
Okay, great. Thanks, first of all, for accommodating my remote presentation, all of you. So I'm at the University of Michigan. I'm part of a group, a wastewater monitoring group with Marissa Eisenberg in public health. So just a little bit about what our team does. We have been part of the Michigan Sewer Network, which is this decentralized approach to monitoring a number of wastewater treatment plants across the state. We look at 5 different wastewater treatment plants in Southeast Michigan. The map is down here on the right with our dashboard that we have. Here are the pathogens or the viruses that we look for. I definitely want to give a shout out to Marissa, who's my co-lead on this, Michelle Ammerman, who's I think in the audience, either in this room or a different room. She really runs this program. And then Julie Gilbert, what I'm going to talk about on the next couple slides is really kind of what she's implemented, and give you some thoughts on kind of data automation. So with that, we can go to the next slide. All right, so we've kind of all got these workflows of what we do, and so we get our we do daily samples of our wastewater treatment plants. So we've gone for kind of fewer plants but high resolution, 5 wastewater treatment plants, but we only get those delivered 2 times a week. We process them in the labs here at Michigan. We have 2 different workflows, one that uses influent, one that uses solids for our more kind of sensitive assays. But what I wanted, and if you want to click, maybe I'll get an animation here. What I wanted to really focus on here is this last step, the QA/QC, and then the reporting, and how much that last step really involves. And many of you know this. So we've got the lab part, but then in our program, we've got all of the checks and validations that happen with our raw data. And some of that then goes to the state. Some of that goes to our University of Michigan partners who want to put it on their dashboard and use it for their information. And then part of it moves forward for our own sake to our own personal dashboards that I showed you on the first slide. And the research that we want to do, our communication with our local public health departments and the different stakeholders that we have. So there's a lot going on in here. And I think a couple of years ago, we realized how time consuming this can be, all of these different steps, but also how prone to mistakes it was and errors. And so we put this effort into an automation pipeline, and Julie Gilbert has really been the lead of that. And what she did is she spent hours with technicians looking at their workflow, looking at how they look at the data, looking at how they identify outliers, looking at how they rerun outliers, and then look at the data and then manipulate the data to post it. So spent a lot of time looking at that and kind of mapping it out. And then that's how she ultimately built the pipeline. So if you want to go to the next slide now. So this is a little bit high level of how this pipeline works. So we have this automated data pipeline she built in R. It takes the files directly from the software. And so every 15 minutes, there's kind of this screen to see if there's new files that have been generated from the technicians. And then there's the data gets put into some central U of M folders, and there are Slack notifications to let us know when these data have been processed. And then there's some separate, after the data's been the QA/QC's been done, the data's been processed and it's ready to go, it stops because we do have a check by our technicians and our researchers at that point to make sure that everything looks okay before it gets sent to the state in one form or gets sent to our stakeholders in another form, or before it gets sent to our pipeline for our own personal dashboard. Let's see, I think there's a lot of Slack messages when things don't go right, when a file's named wrong, or when the QA/QC fails. And then people can quickly go in and fix it. What was happening before is it would sometimes take days to hours, hours to days to go in and fix this data. Now it happens in a much more timely manner. And this really, over time, what this has done is it's saved a lot of technician and researcher time to go through the data. It's standardized it so it doesn't change when one person does it versus when another person does it. It's led to a lot fewer human errors from copying and pasting. And it provides a much easier kind of traceability. When something doesn't look like, we can always go back. But I want to stress that it's this mix of both machine and human. We definitely need to have checks along the way with humans to make sure that everything looks right, and when things go wrong, what went wrong. The next slide. I want to mention that Jules and Marissa are working closely with the Delphi Research Group at Carnegie Mellon to make this an open source kind of maintainable platform that can be shared with others. And a little bit about our QA checks that are happening through this automation. And I'm not saying, I don't want to say that these are right or wrong. They are what work for our process. They are what we were doing anyways in the manual process that now has been automated. And so, we have checks that the pipeline is always looking at the number of droplets that are generated, what our NTCs look like, what our extraction blanks look like, making sure, so we use PMMOV as an internal normalization factor, checking that the PMMOV and that our spiked in bovine coronavirus control are within the range we've seen before, and then looking for outliers. It does pull out outliers, and I'm sure Michelle would love to talk with you about some of the issues we've had with identifying outliers in some of our small communities. We'll set what an outlier is in our big communities, but then that will look different in our small communities. So we've had to kind of be nimble and change over time with that. That I will stop. This is kind of just a summary of our workflow and the automation we've done. I'm happy to answer more questions either in the panel or offline. I'll pass it now to our next speaker.
Great, thanks, Krista. Now we have Dagmara from the Wisconsin State Lab sharing with us. We started kind of small scale, looking at the different QA/QC elements in the lab, how we're implementing those, and now going to a more broader scale, looking at the proficiency testing program that Wisconsin is doing.
Is this your slide?
Yes.
Okay.
No animations, one slide. I thought I had 3 minutes, but I can easily talk about this for more than 3 minutes. So building upon my predecessors here on the panel, sample both on a sampling, data analysis, as well as laboratory analysis, QC is very important. At the end of this process, when all of us do the best we can do in the lab, how do we know that what is the best for me is similar to what is the best for you in your jurisdiction? So this is where we thought in the Wisconsin COE that something akin to, other clinical and, other networks, proficiency testing programs would be important for wastewater. And so we started, I guess it is a year ago. We have another round coming up where the enrollment, I think, is due tomorrow, and we're aiming for ship out on June 9th. And so we're also building this program, starting out kind of smaller, focusing first of all on respiratory pathogens. So what did we do? Basically, we created a larger volume of a homogeneous as much as possible sample. We then create replicate samples and we check, and this is like this churn splitter thing on the left. So you make aliquots and you check, how good your replicates are. We are doing it by turbidity, but then we also do for our internal knowledge and to make sure that what we're sending out, we're doing internal analysis and replicates, right? To make sure that we have really closely tight replicates, that we have a level that we were targeting that is detectable by everyone. So we're shooting for something that is definitely way over limit of detection for majority of methods. And we've done a bunch of different methods in the lab. So we kind of have an idea. Obviously, we haven't done every method out there. We also provide this service at no cost. So as long as you want to do it, we don't really care even what entity you are. If people like Verily or SCAN or CDC or our private partners that are doing wastewater, like Series or Promega or somebody like that wanted to participate, we welcome that. We're just trying to provide it as a service so that at the end of this, when you get these samples that I've just described briefly, we ask you to run your regular protocol. So if we're giving you a sample with flu, RSV, and SARS-CoV-2, we ask you to do what you would normally do for your analysis and then send us the data back. And we capture, which, I'm sorry, very, very long question, and we capture almost everything that we can think of that could influence that result at the end. And we want you to report kind of your raw, like what you read out of the machine, as well as calculated amount, which you would be reporting, except we ask for no normalization. So for jurisdiction that normalize to your spike in recovery or your fecal marker, we don't want that factor. We just want say gene copies per liter. Well, that's exactly what we want. And so this is, if you give me something per mils or something, I'll figure it out because we've got all this other information. But basically we're trying to, somebody mentioned math problems. We're trying to first of all check if mathematics isn't getting us in the apples to oranges comparison right away. And so this comprehensive submission helps us, and the more labs enroll, the more representation we can have of the same method. So like this is an example from our round 2, which was focused on respiratory. The round 3 will include Mpox virus, where the more labs participate with the same method, the more you can actually compare these methods, right? I mean, it's really hard if you have higher variability, which we know in wastewater, no matter what we do, it is going to be variable, even if it's the same sample. If you have only 2 labs, like I think I have an example, maybe here. Oh, and this is split between bulk and liquid, but you can kind of ignore that for now. It's basically whether you're spinning out or filtering out your solids beforehand, or if you're only focusing on solids. So far, we only had 1 lab doing that that participated, or you're kind of taking just the filtrate. So because the recoveries for certain viruses, especially from a spike in, may be affected by which phase you're analyzing. But basically, within the phase, if you have the same method, so like the same shape and color, for example, a lot of people doing nanotraps here, you can then compare to the other method, assuming that you had enough representation to really see what the variability is versus what the mean results. So you can start making judgments about not only has your lab somehow out of all these labs performed lower in recovery? So is there something in your process or in your math that I can work with you on that is affecting you? But also, how are these methods actually comparing for given pathogen? Because the picture is not the same for all the pathogens. And then from that, hopefully over time, we could also provide information on how our laboratory is improving the process over time, if we're repeating the same pathogens with the same method over time. We're hoping that we can also, basically as a community, there are questions that we're going to talk about, I'm sure, here on this panel today, like, how well our methods are performing in this low level, which is a lot of times what we're dealing with in wastewater. We want to know this first measles case, right? How well is our method going to be performing in that low level versus limit of quantification or above level? So hoping to get answers on that at some point will be more tricky. So we're also trying to understand variability of these methods. And if we have enough information and exactly how you do your replication, what exactly is the result that you're providing me? Is it a mean of your PCR replicates? Is it a mean of PCR replicates that is also done on, say, full process replicates? So at the end is an average of 9 data points or 2 or 3. If we can understand that, we can also learn more about what is the largest source of your variability in the method and other things, hopefully in the future. And I'll stop there.
Great. Yeah, thanks for that, Dagmara. Kind of really bringing into this. I know we had some conversations earlier about comparing data on a jurisdiction level, a statewide level, or even a national level. So programs like the fission testing programs help us kind of understand that variability between different labs and different methods. So now we're kind of in the Q&A section of this session. And I wanted to get us started with one question, and then we'll open it up to the floor and let me know if there's some online questions coming in. But we all know that public health moves really fast, and the lab is asked to adapt really quickly. And so the question I had for the panel to get us started was, how do you balance the need to carefully check your data prior to submission and making up a new method while there is still a need to share data in a timely manner? Krista, would you like to get us started?
You got it automate.
Sure, yeah, let's see. So I guess when it comes to kind of routine targets that we're looking for, I think, we've heard from our public health partners that timeliness of receiving data is the #1 thing that they care about, or not the number. I mean, they care about quality, but they can't make decisions without data, without timely data. And so we've really made a priority to turn around data quickly. But there is this tension between turning it around quickly and making sure that it has all the checks. And so I'll just say that I do think the automation has helped because it kind of removes, if somebody's missing one day, we're not missing those steps. The data gets processed and things gets checked, and we trust the quality of the data coming out. And then I think we've set up this weekly cadence. So we know samples get run, one day and then they get posted this day. So we have this kind of regularity to our weeks with some room in case we need to rerun something, some wiggle room. I think it gets a little trickier when we're talking about new targets. And then it's, if you have something that's new and interesting, but how much do you need to check it and validate it before you do share it? And so we just work really closely with our public health partners. We kind of give them a heads up if we see something, but make sure that they understand the uncertainty with the data until we can validate it and feel much more confident with it. I'll stop there.
Do you have anything to add?
Yeah, so I just don't run a routine surveillance lab right now, but I think something that we need to continue to communicate with is the people, especially for new targets and low abundance targets. How confident are you in what you've got, especially if it's a new thing like an mpox? And I will say, when I was at NIST, we were able to develop an mpox standard within 30 days. And was publicly distributed. You can still get it for free online. Federal partners, they want to work with you to make these things happen because it's good for everyone, right? And companies like Twist worked with us too. So I know we tend to stay with the academic or only the public health people who need to be involved in these discussions. But when there's emerging targets, I think it's really important that we talk to industry who has all the gene synthesizers, and they can make lots very, very quickly if needed. And so sometimes it might be on the CDC or a NIST to say this is needed right now. But we don't want to just have the conversation around every lab determining for themselves when is it good enough. I do think we should keep having the discussion and partly on the proficiency testing, how can we make sure everyone's generating quality data so that we make sure wastewater surveillance nationally is of the standard that we want people to be able to rely on.
I was going to add that, yes, and improv. I think how much you can push timeliness versus accuracy also depends on your pathogen and public health goal, given the pathogen in question. So for certain things, when a false positive would be a big alarm and you don't have high certainty, like a new detection in your jurisdiction, you definitely want to have that accuracy, that certainty, and have internal discussions first of all. On other things, we all know we have seasonal flu, and it's not a big, revelation to anybody that we will have flu this winter, or that we will probably have another wave of COVID. So in this case, you could push timeliness, even if there is some QC question or something about your data, and that one point that might be weird on your dashboard, if needed, could be replaced later. So there's context. There's always, which, automation is great, and then our brains need to provide, with our partners, provide that context to really make your response kind of fine-tuned to whatever the target is, whatever the question is.
Great, thanks, Dagmara. So I think now we can open it up to the room or online for questions. If you just state your name and your affiliation, and then ask your question, and correct me if I'm wrong, they can just speak, and we'll hear them.
Oh, online?
Online.
They should be able to.
Perfect.
Typically, we ask them to put them in the chat, but if.
Oh, I was talking in the room, the online here for back there.
Oh, yeah, they
Okay,
can hear,
perfect.
yeah.
So a question for the Wisconsin State Lab. For your PT results, I know you always send out those reports. Will there ever be a time where you kind of give us a perspective on these are the concentration methods that are performing the best? These are the extraction methods that are performing the best, because we all do a little bit of a mix of things. And so it would be really helpful to know.
So I'm hoping to not be the person that tells you my conclusions.
I know it's a lot of
rather look at the report, and it is, I should have pointed out, it is anonymized, so your lab number and you just see that number, and so yeah, maybe you can figure out if there's only 2 data points and you kind of heard that somebody else is enrolling than they stand, but it's anonymized. But you can kind of figure out, it's not meant to be, a finger pointing or penalizing or anything. It is to serve the common goal of basically all of us getting better and being more interlaboratory comparable, better data set for like news and stuff like that. We have a plan to write a manuscript really soon. Martin, I hope you hear me. On our 2 rounds of PT, the more people enroll, and we have like limited capability where I don't think we can serve more than 50, maybe 50 something, but we've been getting like 30 something. So there is room for growth. The more people we get, especially with like the same methods, the more power. You need to have basically, as you know, statistics work that way, right? Basically larger numbers before we can actually really make these statements. So like, yes, I can tell you that this data set suggests that this is better, but maybe in a different data set, and especially with a different pathogen, this concentration will actually be great, and here it looked bad. So I don't have we have noticed that InnovaPrep has resulted in some of the lowest recoveries. And again, this was with spiked in, influenza A, B, and RSV was spiked in both times. So that could also be a slightly different story if it's a native, kind of endogenously present shed pathogen. And then also if we have more labs participating, because I don't know if I just happen to have those 3 that happen to have, for some reason, a lower recovery. So I'm not making grand statements yet, but we're hoping to get a publication out there. And the more people participate, the more rounds we have, the better the data set, and we can then hopefully have a webinar or something.
But I guess to add to that, something I think when we think about standardization, people are like, tell me what to buy so that I can do the thing so it's exactly the same. But in terms of if you're a state agency, or at least when I was a federal employee, you weren't allowed to endorse companies.
Yeah.
Like you don't want to pick the winner. That's what they call it when you're telling everyone what to use. It also might create supply chain bottlenecks. And if we were in a situation where we all needed it right now and we all are ordering the exact same kit and none of us have ever done it with any other kit, you can create problems so that all your sites are down instead of just a couple sites. You also want to be cognizant that every lab and state has different resource constraints, so that if we're developing expertise, that if we're developing methods for a SARS-CoV-2, those might not be the same as methods if we want to do AMR, right? That's a very different target. And while some labs might be able to automate everything to the moon, some of us are running things by hand. And so that maybe comes with time considerations, but I think from all of the proficiency testing, we also want to help create metrics that enable better comparison without picking the method. Are there recovery ways we can think about this?
And I think from what I've seen over time, it's basically, which is a good thing. Initially we were all like, oh, can we just standardize the heck out of this thing and not think about it and make it simple? But then, hey, next pathogen comes around and you can't really, because you have to still pivot and revisit everything you've ever tried sometimes. The good news is that from everything that we've done in the lab so far, and I've been at this since the very beginning, and we did a method development, and by the way, Martin's favorite word is variability. We need to understand the variability. There's so much variability at every step to understand. But whether you compare qPCR to dPCR or all of these concentration extraction methods, and I didn't give an example of the extraction differences, because in the last round, I think we had 10 different extraction kits. The good news is, overall, if you look at this, it's within a 1.5 order of magnitude that everybody performed for at least SARS-CoV-2, maybe 2 orders for flu, and that was also a pretty low level for one of those pathogens. So then big picture scheme, all of these things can be working really well if you're really careful with having proper controls at all the important steps and doing your QA/QC.
Mm-hmm.
So that just, it would be informative for labs that are starting out or that do need to, for some reason, adopt a different method or switch methods. It's good to have this information, but it is not to say that you can't get good quality data with a method you already have.
And I guess I was involved, so Ontario province did a lot of proficiency testing historically in Canada, and I was helping with their technical advisory, what do we do with all this data and how do we think about it? And one of the things that came out of that, Alex Chick is leading that, he's wonderful. One of the things that really came out to them and when I was working with them was the time, so the changing the method actually caused way more problems than picking a method and getting good at it. The time that a lab had been doing the same thing reduced their variability much more than trying to pick the best method and constantly tweaking every single thing every time. I mean, as someone who's been a bench scientist, like it creates a little bit of anxiety and chaos when you're trying to, like, you're changing every variable all the time. So a little bit is just being consistent, deciding like maybe we're not the #1 quantification every time for every target, but we're like in the middle and that's okay. Like that might be fine. And just like Dagmara said, just because you perform well at a mid-range target doesn't mean that if you're near an LOD, you're gonna perform as well. So it's really gonna be variable.
And again, depending on the pathogen, maybe all you really care about, even if you're offset by an order of magnitude, that your trend lines are good. And if you have less variability, and so you have better trend lines, maybe you stick with it, even though you're lower. So again, it kind of depends. You have to think about the whole picture.
And costs, like to change everything, is usually not minor.
Great, I think we have an online question.
Yeah, there's a question for Krista from Emma Dempsey with UNC Chapel Hill. Can you expand more on how you establish reporting standards and identify outliers in your high-resolution wastewater data, especially when comparing treatment plants that serve different population sizes?
Yes, I can speak a little bit to that. So in terms of outlier detection, so the way that we do it is use a 7-sample rolling average. And then we look for outliers based on that 7-sample rolling average plus or minus the standard deviation of those 7 samples. And that's how we identify an outlier. And that's what we've used for a really long time. And that's how we've programmed it. But we noticed and that worked okay. And I'm sure there are more sophisticated ways of explaining what okay is. And I'm sure my colleagues have done that. But I think we've been happy with how that's worked. But we did notice recently that at our smaller plants, what happens is when that standard deviation gets really small, and then there is a quick, because those smaller plants, the dynamics we see in the high resolution data, they pivot so quickly, we were calling things outliers that weren't really outliers. And so just recently we went back and kind of expanded or I should say, we've become less strict in what an outlier is in some of those smaller communities. And so we've been adapting as we go. That's where we're at right now. There's a new definition that's much more, it's not as easy to roll off. It still has to do with the 7-sample rolling average, but it's like if and when, then it changes a little bit. I also want to mention, I meant to about our detection limit. So, we're part of the state network, and the state network kind of defined what a detection limit was, and it was 3 positive droplets. But we found over time that was a little bit too strict. We felt like we had a really, really low baseline. And so over time, what we've started to do is use kind of a combination of what the ddPCR instrument tells us based on that plate, kind of what they say the detection limit is. But then because that can maybe overlook some trends that we've seen over time by plate, maybe some things that pop up here and there, we do kind of have a little more complicated detection limit that looks at either like the worst of like the detection limit that comes off of the instrument and kind of a statistic of the baseline of the last 10 or so plates. And so that's what we use for detection limits. The trick is anytime we change this, now we've got years worth of data that we've got to go back and modify. So we try to only do this and, change our definitions when we really think that, there's enough data to justify it. And then we have to make a note of it on our dashboard and always call that out with our historical data.
Any other questions in the room?
Maybe, what's your current schedule for your PT? Sign up, how often you get to sign up for PT?
So the next one is coming up pretty shortly here. We're already kind of behind. We are hoping to do it to really measure the endogenous levels, which I'm trying to get as much as possible. We would like to be doing it somewhere where it's not right before Christmas, which is what happened last time. But during the peak season, where we have access to reasonable, robust endogenous levels. And it's hard when you're trying to because we really were trying to target both RSV, influenza A, and SARS-CoV-2, and get like, you know, we have relationships with wastewater that are pretty good, but also like we want to have a nearby source that we can do this baseline and other work in. So the long story short, I'm hoping it's gonna be twice a year and it's gonna be targeting endogenous and like I'm hoping late October, November season, depending on what the viruses decide to do. And then something that might follow in the early spring. So it could be, for example, we have peaks of influenza B at that time, and we could be adding other pathogens of concern. And then it would be kind of a hiatus over summer. And so that's the current thinking, twice a year, maybe trying to span the respiratory epidemic season.
Thank you.
And how do people sign up for the PT program?
We usually advertise it via email as well as on a bunch of like COP calls. If you're on any of the calls, we try to participate in both the utility and public health when it's going and the laboratory COP wastewater community. I don't know if everybody has seen these or emails, but it's basically a link. So like hopefully we're working on a website for our COE and we can just have them there and then everybody will know where to go. This is something that is in my court and it has been in my court with a couple of people. Some of them left already for like a year, but it's finally happening. So if that happens soon enough, then maybe before the next one, it will actually be on our website. But the long story short, right now we're just advertising and you can always just email us and we will definitely send you a link, and a bunch of people that have already participated knows exactly, you know, who we are and where to go, so.
Thanks for that. Yeah.
I'm Monica from the North Carolina State Lab of Public Health. And I think my question's for Krista, but maybe for anybody else. Have you found any other normalization strategies other than PMMOV that work well for like different jurisdictions or different other like wastewater treatment plants or geographical locations?
That's a controversial topic. We've you know, we haven't done too much research on normalization. I think there's been probably some nice studies done on it. We picked up PMMOV. I worked closely with SCAN early on, and SCAN was using PMMOV, so we kind of like went along with that. And then once you kind of get into a routine, it's hard to change that. So I never ever want to claim that PMMOV is normalization all the time. I know for a fact that we've done some modeling of PMMOV shedding, also cross-phase shedding, and like the difference with different people, and people shed very different levels of PMMOV and cross-phase, and day to day it changes. And so we did find kind of in ideal sewer sheds, when everything is perfectly mixed and recoveries are perfect, that when you start to get below like 10,000 people, because of the variability in the shedding of CRAS and PMMOV, it can create some problems in your normalized data. Our sewer sheds are all larger than that, so we've stuck with it, but I definitely want to claim that PMMOV may not be the right one, and other people might we stick with it because we always have. Other people might have some comments on that.
Yeah, I think to that point, like we're doing more bacterial target detection in our lab, and we're on the research side from the surveillance research. We're definitely on the research side in my group. We're looking more at HF183. We're sampling systems that are all, so when we're looking at bacterial targets, HF183 is a kind of established microbial source tracking indicator. So a lot of labs might already have it through your beach monitoring program. There is already a standard reference material out for it. And there's an EPA method. So these are all great things that we like do the assay. But partly because we're looking at bacterial targets, we think that it will perform more similarly in our concentration methods. And we are in a really rural area sampling really, really small systems. So those PMMOV variations and those cross-phase variations, like our treatment facility is serving 7,000 people, 14,000 when the students are there, but that varies. And then we're also sampling lagoon systems that are, again, serving 200 in the winter and 10,000 in the summer, or 500 year round. So they just vary a lot by size and they have huge inflow and infiltration rates. So it's really important that we can normalize to something that isn't that variable. But again, we haven't played too much with the viruses because Krista's doing a great job at that. So we're focusing more on the weird bacteria.
How about you, Dagmara?
I don't think there's not one size fits all, and there's not a standard. Like, unfortunately, basically you need to look at your data. You need to look at your data and then decide if any normalization event is helping. That slide that I provided to you in an email, like we were thinking we were going to be talking about this, is like when we did an analysis, and by we I mean like we're in my lab, I think it was like 24 or more different permutations of treating your data and taking the data for all of our sites, which we started out with 72, now we're at 44, so let's say 44, and taking a long time span in SARS-CoV-2 where you had good clinical data results, and so trying to kind of see which normalization would actually help with trends and correlations with clinical, and basically nothing really makes a big difference. For some sites, maybe something would make a difference, but not great. For a lot of them across the board, that just made things worse. In our hands, at least, and Wisconsin has very few combined sewers, there's infiltration, and yes, we have thaws in spring and we have storms. But for whatever reason, in our network, at least with the sites that we have, nothing has caused a great improvement. On the dashboard, we are normalizing to flow and population. So basically, population is not really what who really actually was in the sewer shed on a given day when it was sampled, but just like the static number of who lives within the sewer shed. So that's basically divided by a constant. So the only thing you're doing, you're kind of trying to get the viral load via flow, assuming that the usage per person is the same, and so that it should make a difference. However, sometimes that flow actually is making things worse. Normalization to flow, I should say, for many different reasons that I can come up with, and we can get into it if you want to. So not a golden bullet or one size fits all. I think it really, again, depends. Like, if you really care about trends, look at what is minimizing your variability and getting your trends better. And if it's unnormalized data, go with that. We have tried HF183, cross-stage, BMMOV. Our partner in Milwaukee really loves LACNO. I don't think any of those actually panned out, or at least not in a way that, would make us feel like, yay, let's do it. So.
Any other questions in the room? Yeah.
I'm Syed from Citizen Science. I have a question about the process control. Having a negative process control and a positive process control seems necessary if you want to make sure there's no contamination, and also want to make sure the entire process is working as you expected. Mm-hmm. What I found is having like a clean sample, like a PBS or water, is not doing great as a control. You see a lot of false negative. If you spike them and you process them, you will see it's not behaving as this wastewater. That's one thing that I see. It seems like we don't have any standard media or metrics to serve as a control. So I'm going to get your idea and feedback on that.
So at some point, NIST was working on, I'm going to bounce it to her.
We're working on it. NIST, we've been working for a minute, and it's partly because I left and then have a different job, but they're working on it.
It's all your fault.
Yeah, like we're working on developing a synthetic wastewater material and evaluating different synthetic wastewater recipes that have been used for more like bioreactor maintenance. And right now we're in the process, we were evaluating ASTM method and then the cat food method, which is, I guess, a very prominent one, for trying to get the humic and fulvic and inhibition that you need to be closer to. It's not gonna be your wastewater, I can promise you that. It will not look like anybody's wastewater, but it might look like a wastewater. The goal is that it will have humic and fulvic acids. It will have inhibition present so that there's something to challenge it with. And it has solids so that you can spike in targets and there's something to sorb to. What we're working on now is long-term storage. So at NIST, what you look at when you're making these things is homogeneity and stability, especially across lots and batch variation. So if we sent a recipe out to everyone and it was like buy your local seafood medley Purina cat food, which is what that one uses, like, is that available everywhere? One, honestly, then you're really dependent on the seafood medley batch variation, which might be fine. But then the question is, how long can you store it in the fridge? How long could you spike into COVID and store it in the fridge? Do you need to make a new batch every time you do it? Or is it okay for a while? Should we autoclave it before we spike that in? Does that cause chemical transformation of your acids? Does it work for fungal targets, bacterial targets? So that's what's happening right now, is trying to figure out what's the most representative one. We're comparing 2 synthetic wastewater recipes against 4 field collected wastewaters, as well as like autoclave versus unautoclaved, because real wastewater isn't sterile. I think there was this large push at NIST that we should autoclave it, and I was like, yeah, but it's never gonna be sterile. So like, they were like, we have to use molecular grade water. I was like, why? Trying to replicate wastewater. So keeping the cost down for what people have to manufacture. And then is it NIST, providing a recipe, which could be a documentary standard. There's also the ASTM method, but that was really developed for, I want to say it was like solids assessment. But we're trying to figure out those things.
Is it available, the recipe for cat?
The ASTM one is available. There's a synthetic wastewater one. Again, it wasn't developed for molecular assessment at all.
I think I saw that with the flour.
Yeah, with the flour. So the flour is a bunch of E. coli in it, which can cause issues. Which is fine, but that's what we're thinking about. And then the seafood medley one, it was really hard to find, but people kept saying it exists. I can send it to you if you can give me your email.
Sure.
But to bounce it back to you, you know, what is your need for that? Like, because to me, no matter what kind of artificial wastewater you find, or even like we have in the lab, you know, wastewater from like frozen repository, for example, from before COVID, you could use it as your spike in. And you could probably, if you've been doing it for a while, have your own standard that you have created by pulling things or whatever. Like, let's say before measles, you have your negative, and then you know, hopefully not everybody's gonna get measles. But anyways, so like, I guess my question to you is like, what is your goal for that, and what is the reason? Because like, we know that if you spike in a virus, let's say B. coli or something else, whether it's in PBS or TE, or actually I wouldn't recommend water in any case, but something else, other matrix, it is not necessarily going to mimic your target that you're trying to quantify, right? So knowing that it's not going to be perfect anyways, maybe you don't need to have this very particular specific wastewater standard, and you just need to know what the recoveries that are acceptable for both your blanks as well as your sites are, and kind of establish that baseline, and you know, like basically have a run chart of like, this is how it normally goes. When something goes wrong, it's 2 orders of magnitude lower or higher or whatever, you know, and then go from there.
I think the point is like, just normally, how the performance is normally happening is really depend on your matrix. Yeah. So yeah, you're right. You can have the full wastewater, but at some point it's gonna go away. Like you're gonna finish all of the full wastewater, and then you have to collect another one. Plus, when you want to like do comparison between the different labs, you need to have a standard media to do the performance check, like across the different labs. That's one issue. Another issue,
But so that's what the PT sample really does, and we do ask you for like, what was your recovery and what were other things.
Yes, sure, but the controls need to run every day, like running along the sample. PT is like twice a year. It's not catching the entire, you know, the daily process.
No, it doesn't replace your normal day-to-day QC,
Sure.
obviously.
Yeah.
But again, like if you know that, for example, in your samples, normal recovery of your BCO spike is 40 to 80%, with whatever method you're using, but for your PBS control that checks for, how clean your system and process is, that recovery is only 5 to 10%, as long as it is 5 to 10%, you're good with, like, you don't care that it's that different. Why would you?
That's could be, but for PBS, what I saw is depending on your method and your extraction, you might get a
You might
sense of,
not recover, yeah,
you might not recover it.
yeah, I understand that.
And it's different from wastewater. You test in wastewater, you need a standard similar to wastewater.
Yep.
So I think having a standard media will resolve a lot of those challenges and questions.
It will help.
It will help,
Yeah,
yeah, it won't
But I
solve
don't think it will, yeah, exactly.
And I guess I kind of see, or I've been very public with research articles about pushing the whole field towards mandatory proficiency testing for public health labs, because again, if we want people to trust our data, we have to show them they can trust our data. And that comes with some of this routine, QA, QC, that looking at like over every plate, what's our actual variability. So I mean, I agree, I think that's why we were working on the synthetic wastewater, but in the meantime, there are a lot of things you can do, and I also don't think the synthetic wastewater is gonna solve it.
I think I would rather have like a national repository of known wastewaters positive for XYZ, that everybody could get both the extract aliquot and the wastewater aliquot and then run through, and then say if you, at the end of it, pass criteria.
Yeah, I think there's a lot of different ways you could go with it. I do see, especially if you're thinking like, I guess I've talked to like a Eurofins or a company that's trying to run many, many different labs, and they have internal QA QC across labs. And the idea that every lab could handle every different thing. I guess I get where you're coming from, but I also think that in the meantime, people have done a really good job, and it really starts with knowing your variability. And if you're just getting started and you're like, I don't know it, run 10 plates with 3 different people and you can figure it out. Like, that will give you your range. But just start running plates and start figuring it out. Like, it's.
And as a field, we can come up with recommendations what a reasonable variability is, or a reasonable recovery with a given method is. But again, we can't test every wastewater everywhere, and so you will take those recommendations and ultimately look at your data. Like, we are all constantly learning from our data sets, right? And so, like, for example, if you want to have wastewater, maybe you already have access to it. Maybe somebody else has a large repository of things that you could just pull and combine and have your standard for a while. Just things around that. Let's say you don't have to do it, with every analysis. Maybe you only need to spot check like your components in your process weekly or monthly, or there's ways that you could implement something that you're more happy with.
And something we haven't talked a lot about in this space, but I know at least that my lab has anecdotally been a problem, and I've seen it anecdotally across a few different labs now, so that it's maybe a trend. That like wastewater processes are inherently variable. Like, what goes into your wastewater is gonna be inherently variable based on the industry. Every day is gonna be variable, and then like seasonally, maybe that's a dilution thing. But some wastewaters are gonna have more inhibitors than others based on the industry present. And so even if we have a synthetic negative control, I honestly think for some labs, for some wastewaters, it's not gonna work. Like, I've been at utilities where, you have an industry who's dumping in a ton of iron, and you wanna know what's great for PCR? Iron inhibition. Like, it just destroys nothing's gonna work, right? And so that's this communication piece we keep coming back to, but it also would be a place where your standard for your negative control might look good, your positive control might look terrible. And then you have to start to figure out if it was just a positive that wasn't like a spike positive or recovery positive, you have to teasing out exactly what's happening, I think gets to be really, really, really important. But knowing your sewer shed is.
But I think if you have like a good standard, like a positive process control, then you can say, okay, my process worked. The problem is the wastewater sample.
But
That's
I think
probably-
if your
it's not negative,
process, if your process control does not represent the wastewater that you're testing, what is, like, for me, a positive control could be more of like I spiked something
I
in
mean,
and
you will
got it
flag
out.
that there is a problem, I guess,
Yeah.
what you're
Yeah.
saying, and then you
Yeah.
can drill down, because you can't do anything about something that you don't know anything about, right?
Right.
Like,
But I also
first, I
think
think you have a problem.
if you got 0 PMMOV, that would also flag something. Like those
But
internal
PMMOV
ones.
can be completely different story, you get
Right.
PMMOV really nicely recovering while your pathogen, so yeah,
Yeah.
it's complicated.
I think this like, discussion
Yeah.
about flags is really interesting. I'm wondering if Krista had anything to chime in there with like the automation of the R script. If you could share some of those flags with us, like say for negative controls, which you first started with, or for other kind of data quality elements.
I didn't catch all, what was, I heard I could pitch in on some controls. What was it specifically?
Yeah, so this question started with, different sources of negative controls and wondering if how you could explain those flags in your R script for negative controls and processing controls.
Yeah, sure. Let's see. So we have, we have kind of like a script about what gets flagged with our negative controls. So I think we allow up to 2, possibly 3 positive droplets in our negative controls. We look at, I think we look for outliers. We look both at PMMOV and BCOV from the last, I don't remember what the history is, but we keep, I think, long time of history on our PMMOV and BCOV, and then if it's like outside of 1% of what that, or if we're less than the 1% outliers, then that gets flagged. I do want to, like, I guess I do like the idea of the problem with recovery has always been a problem, right? Like with BCOV, it's all over the place. We always spike it into the same kind of distilled water, but I think it is because oftentimes there's not other stuff in that distilled water. And so I do like the idea of having our positive controls be spiked into some kind of standard positive solution, just so that we maybe get more consistency from run to run. So that's, I do like that idea, because with us, it's just, we're not really looking at recoveries except for just, is it a crazy number? If it's a crazy number, there's a problem. We don't have some kind of tight analytical recovery requirement like that I think you can do in chemistry sometimes. I don't know if this has been helpful, but I do like that idea.
Great, thanks for that, Krista. I think we are about at time, but thank you to all of our wonderful panelists.